Hello, everyone. This is going to be our last lesson. So hopefully you guys all had fun so far. All right. Okay, so hello, everyone. Yeah, this is going to be our last class. So this class is going to be pretty easy compared to the other classes. So if you did well in the other classes, you're gonna breeze through this class.
Yeah, actually, this class doesn't really involve anything related to the other classes.
Yeah, it's just like surface areas and volumes.
Yeah, it's called measurements.
Yeah, measurements.
Okay, so I think we should start.
Yeah.
What other classes like the previous lessons? Yeah, we were just doing unit conversions and stuff.
Yeah. This unit is
Yeah,
mostly memorization.
okay. Yes, so let's start. Okay, so the first thing we're gonna go over is the different types of units that we're gonna use. So the first one is called the SI units or the metric units, as you might know it. It's kind of like the ones we use. It's like kilometers, well, not meters, liters, and stuff like that. So let's go over that first. So we're pretty I think all of us are pretty familiar with this with science class. Yeah, everywhere but USA and some other random small countries.
Yes. So
Okay,
just let me write it down. km, meters, etc.
and seconds.
Okay.
Yeah. And there's also kilograms and other stuff like that. But it's what you're going to use in physics, science, basically anything related to science, because it's kind of like the world standards. It makes a lot of sense.
You know what? Should I just
So,
like write all of them down?
yeah, I think we could do that.
Okay. So there are 7 SI units. The first one is. Oh, wait. Am I cutting out?
No, you're totally fine.
Okay. Then. Okay. So there are 7 SI units. The first SI unit is km, which is for distance. The second one is kilograms. Oh wait, sorry. The first one
Wait,
is meters.
yeah, meters.
Meters for distance. The second one is kilograms for mass. The third one is seconds for time. So I'll just denote it as S. The fourth one is amperes, and that is for electricity current. The fifth one is K kelvins, and that's for temperature. And then we have mole, which is mole is the amount of substance something has. And then the seventh one is candela, and that is just for the unit of brightness. So you don't need to remember all of these, but just know like the distance, meters, and like kilograms, seconds, newtons. So newtons is actually what we call a derived unit. That's a good question. 1 Newton is actually made up of these fundamental SI units. So 1 Newton is 1 kg per second squared. And as you can see, it's actually made up of the kilogram, the meters, and the second. So the 7 fundamental units make up what we call derived units. Okay.
Okay, so I think we should move on to the next big thing about metrics, which is the prefixes.
Yeah, sure.
So should we do that? Okay, where do you want to start? Because it's kind of big.
We can just list all of the prefixes.
Okay, all of them? Uh,
Um, a few of them.
if you okay, a few of them. Okay, let's just start at mega. Okay, so mega, it's just the symbols capital M, and the multiplication factor, which is basically how big it is compared to the base unit, is 1 million, so 10 to the 6. And then the next one below it is the kilo, which is just a K, and it's a multiplication factor of 1,000, so 10 to the 3. And then below that is hecto, which is lowercase h, and that's just 100. And then below that, and then we have deca, which is lowercase da, and that's just a multiplication factor of 10. Kind of weird, but and then here we just have no units, so this is just a base unit, multiplication factor of 1. And then below that, we have yeah, base unit. And then below that, we have the deci, which is a lowercase d, and it's 0.1, so 10 to the negative 1. And then we get to centi, which is kind of common, which is just lowercase c, and is 0.01, which is 10 to the negative 2. Then we have milli, lowercase m, which is 10 to the power of negative 3. Isn't centi? No, it's smaller. And then we have micro, which is a weird mu. It's a Greek letter. I'm not sure, but it's 10 to the negative 6. Oh, okay. And then there's stuff below that and stuff above this, but I think those are the units that you're most likely going to encounter.
Pica thing.
Yeah, it's below micro.
Micro? Like, wait, what is it again?
It's nano and then pico.
Yeah, it's nano and
So
then
nano is 10 to the negative 9.
no. And then there's some weird thing called like angstrom or something, which is like used for the radius of like atoms. And then we have David's what is it again? Like
Pico.
Yeah,
Yeah,
pico.
pico, which is negative 12.
Okay, I think that's enough.
Yeah, because I think anything aside from these, you're like very rarely going to encounter.
Yeah, exactly. So like, do you want to do like an example with meters?
Sure. We can convert like 10 meters to, for example, how many hectometers?
Yeah. So HM, I don't think that exists, but let's pretend that does.
So what we do is that we just multiply it by the multiplication factor. Wait. Oh yeah, it's a decameter. Okay, I got you.
Yeah.
And
So-
then to get from, oh,
Sorry. You can go.
okay. And then to get from decameter to meter, we just divide by the multiplication factor. So we get divided by deca, which is 10. So we get 1 meter. Wait, hold up. I'm confused.
Yeah, you're right.
No, I think we went the, wait. What are we doing right now?
Let's use like centimeters because I think everyone is familiar with it. So for
Yeah,
centimeters, we can do something like 1 cm is 1 times 10 to the negative 2 meters. So if we flip this, we get 100 centimeters is equal to 1 meter, which we all know it's true. Or something like micrometers, 1 micrometer is equal to 1 times 10 to the negative 6 meters. So 1 million micrometers is equal to 1 meter. Okay. Do you think that's like enough?
should we do one more example?
Sure.
Here, let's convert how many nanometers is in a meter.
Okay.
We have 1 nanometer, which is equal to 1 times 10 to the negative 9 meters. And then we can also flip this around. Yep, 1 billion. So 1 billion meters. Wait, 1 billion nanometers is equal to 1 meter.
Yeah. Okay, so conversion factor, well, we should just call it like orders of magnitude.
Yes, that sounds good.
Pico is 1 trillion. Yeah, it's 1 trillion.
Yeah, I think we should give them an example.
Yeah, sure. Which one?
We can convert 3. Okay. Convert from how many nanometers and 3 meters. Okay. I think that one's quite easy though.
Yeah. So 3 meters equals to how many nanometers? $3 billion? Yeah, good job.
Yeah, 3 billion.
3 billion.
I think you should teach how to write in scientific notation.
Yeah, sure. Let's do that next after this.
Okay. Should we do another one?
Yeah, we should do like between two different orders of magnitudes, like milli to
Between
nano.
different. Okay. Yeah, that works. Do
So
like 12 milli to nano. Oh,
12.
you can do 1 milli first.
1 milli equal how many nano? Yeah, sure. Does anyone have any ideas? Oh, 1000? You're really close.
Almost there.
Almost there, yeah.
Hey, this is exasperatingly large.
Yeah, really big.
What was a milli again?
Milli is 1 times 10 to the negative 3.
Yeah.
So 0
He's going to blow my head off.
Yes.
I think we have an answer in the chat.
Oh, 1 million? Yes, good job.
Yes.
Okay, nice. Should we move on to using scientific notation?
Are you supposed to remember all of these since it's going to blow my head off?
I
Uh,
don't think you'll have to remember it.
Not now, but eventually
Yeah.
you do. In
Like
high school.
eventually, at least remember like most, not like maybe not all.
Eventually, I'll have to remember all of them. Ah.
I mean, I don't think you have to remember stuff like deci, deca, but maybe like the more common ones like centi, milli, micro.
Micro. We're not
Yeah.
so common with micro.
Don't worry, you'll be fine.
Yeah.
Just the more you use it, the easier it is to remember.
Exactly.
Okay. Should we talk about scientific notation?
Yeah, sure. I can do this part if you want.
Oh, okay.
Okay. So as you can see, as what Alex said, these numbers can get really, really large or really, really small. Now, since scientists and mathematicians are pretty lazy, they don't want to write like 100 zeros. So that's why we have introduced something called the scientific notation. The scientific notation is just another way of writing really large or really small numbers and an easier way to write it. Greek, Latin. Yeah, I think they're Latin roots. So anyways, scientific notation goes something like this. It's a times 10 to the b, where a is between 1 and smaller than 10. And b could just be anything, like an integer or something. So for an example, if we have the number 3 billion, we can convert it to scientific notation, which would be 3 times 10 to the 9. As you can see, 3 is between 1 and 10, and this 9 is just the b. It's an integer. So the second way, the scientific notation, is much shorter to write than like the left large number. Another example would be 0.000001. In scientific notation, that would just be 1 times 10 to the 1, 2, 3, 4, 5, 6, negative 6. So again, Scientific notation is just a much quicker way to express large or small numbers. David, do you have anything to add?
I think that's all, but there's also significant factors, significant digits. Yeah, I don't know. Should we get into that?
I wasn't
Oh
taught that.
no. Hmm.
Yeah, we weren't taught that in grade 10 math, but
Oh, really? Yeah. Oh, yeah, that's true. But like,
Oh, good.
it's too hard. Let's skip it.
yeah, I think understanding scientific notation's pretty good right now.
Yeah.
Okay. Yes.
Wait.
So should we move on to the much more fun units?
Yes.
Okay, so let's talk about the imperial system, the totally world's greatest system with very obvious ways of conversion. Okay, so you don't have to remember all these conversions. You're like really unlikely to use imperial system in school, other than if you're doing like measurements unit in math.
Wait, are these
Oh.
like the common ones used everywhere in the world, like centimeters and decimeters, or are they going to use the? Oh yeah, it says USA, right? But they're doing like miles and feet. They're really not like tens. I like tens where tens are easy.
Yeah, and I gotta agree with you on that. The tens are better.
Yeah, exactly.
12 degrees.
Oh,
That's very true,
And there
Patrick.
are lots of kilometers in a mile, and I can't. No, I think there were 2.56 centimeters in an inch. No, I think it was a 2.57.
yeah.
Okay.
Great. Okay.
Yes.
Let's move on.
Yep.
Imperial
Let's start
system.
going into this. Okay, so let's start off with like the weights. Okay, so here we have 1 kilogram, which is a metric unit, and if we want to convert it to how many pounds, 1 kilogram is equal to 2.205 pounds, which is a great start. We obviously have really nice numbers like 2.205. Okay, and now let's move on to the distances. So we have 1 inch, which is imperial unit, and to convert it into centimeters, it is equal to 2.54 centimeters.
Just
And then
remember the
here,
one oh sorry.
oh no, you can go.
Okay, just remember the ones I highlight with the star. Those are the important ones.
I thought it was 2.5. Yeah, you can use 2.5, but like the numbers just like are really random. So you can get like a lot more decimal places behind it. But
Yeah.
it's just, yeah.
Oh, whoops.
1 kilometer. Oops, 1 kilogram. Yeah, I don't think you'll ever convert a kilometer into pounds. Okay, and then next we have 12 inches, which is equal to 1 foot or feet. I don't know what it's called, but it's FT. And then we have 1 foot. We have 3 feet, which is equal to 1 yard, which is a very interesting way of measuring stuff. And then for the last one, which is a little more common, which is 1 kilometer is equal to 1.609 one mile is equal to 1.609 kilometers.
Great. I don't. Yeah, you only need to remember the 1 point inch equals 2.4 centimeters, and let's remember the imperial system conversions. Then you only need to know one of the transversals from like the imperial system to the literally more common system to and then know the conversions for each one to be able to understand it.
No, that's true actually. You only need to know one of these because then you can just so like if you remember like just remember this one, then once you get to inch, you can just use like 1 times 12, 1 times I don't know. You don't need to remember all of these if you just
And how many yards in a mile?
how many yards in a mile?
Yeah.
Okay, that's a great question.
And Edward, I think there's only just two systems. Maybe there's like a much more obscure one, but these two are the most popular.
Yeah, so apparently 1 mile is 1760 yards.
But yeah, that's nice to know.
Yes, nice number.
Finally, something that makes sense. Okay, so I guess you can try to do a conversion question with it, just like a couple.
Sure.
Yeah, we can convert for example, 12 inches into how many feet? Wait, no,
what?
wait, that was a really bad example, isn't it? Okay.
Yes.
Yeah, here, let's make this much more interesting. We can do 50 centimeters into feet. But yeah, when working with Imperial, you never get nice units.
So yeah, should we just do this one together?
Yeah, let's do it together.
Okay.
Okay, so the first thing that we got to do is that we have to convert the centimeters into inches. So it's 2.54 centimeter, gives you 1 inch. And then next we convert the inches into feet. So we have 12 inches, which gives you 1 feet. And that should be the entire question. So if we calculate this out, we get something around 1.64 feet. That's nice.
So this is called unit analysis, if you're wondering, because we're canceling out the units. Uh-oh, David, I think you're cutting out.
What?
Oh, were you not speaking?
Oh yeah, I wasn't.
Oh, okay.
Here, should we do another example?
Sure.
Okay, so convert from 5 kilometers into yards. Hopefully this is okay. Yep, so we gotta first convert kilometers into yards. So the first thing we do is that we convert kilometers into miles. So very nicely, 1.609 kilometers is equal to 1 mile. And then we have to convert the mile into yards. So 1 mile is equal to 1,760 yards. So again, if we do the unit analysis, we get roughly 5,469.2 yards. Yep. So I think that's all for the units.
Yeah, I think that's enough.
Yeah. Okay, should we want to move on to like area and volume?
Yeah.
Okay,
Okay.
so this will be fun. Area and volume.
Wait,
So
I was
it's just
just.
gonna,
Oh, sorry.
yes.
I was looking at the document. Do you want to do the arc length, or should we just skip it?
Wait, what?
There's an
The arc
arc
length?
length. Should we just do it or no?
I mean, we can teach it.
Well,
It's not gonna make much sense, but
yeah, like I wasn't taught that, so we can let's just skip it.
yeah. Can you go up for a second?
Oh yeah. Okay. Area and volume. Let's start with a circle.
Yeah, I think these are pretty basic.
Yeah, it's just review.
Here, do you want to do the sector and arc stuff? I mean,
Not really.
Ah,
Because it's
okay.
not tested in grade 10. It's a math 12 thing.
True. Okay, yeah. Okay, let's do circle. So pretty sure everyone knows this. It's equal to pi r squared, where r is the radius. And then next up, we have the area of a triangle. So the formula here is b times h, which is base times height divided by 2. Yeah, or 1/2 times b times h. And then the next one, we have the rectangle, the simplest of them all, which is L times W, which is length times width. And then we're going to skip the sector stuff. And we're moving on to surface area. So surface area is the area of a 3D object. So it's a surface. So we have the surface area of a sphere, which is 4 pi r squared. Oh, we're gonna get great artistic rendition.
Of a sphere is
And there's probably like a bunch of great explanations on why it's just 4 times the area of a circle. But I don't think we're gonna cover that.
unfortunately not.
Yes. So now I think that's the only surface area that we're gonna talk about.
Really? Okay.
Yeah, we can do some other ones later. Like we could try to developing some.
What the
Okay, sure.
only thing for surface area is a sphere?
I mean, there's some other shapes, but like a sphere you're gonna encounter quite often. So
But how about the cylinder? How about the triangle pyramid?
well, we can try developing the surface area of a cylinder later.
See, like Alex, what you're saying is a cylinder, right? But like surprisingly, a cylinder is made up of 2 circles and a rectangle.
Yeah, that's 2 pi r squared plus the
Times height.
r pi times height.
Yeah.
Oh, yeah, you just remember.
So like those are like the derived areas, right? We're only learning the fundamental areas right now. But yeah, it's great that you brought it up. Wait, should we move on to the volume of a sphere?
Yeah. Okay. So the volume of a sphere is 4/3 times pi r cubed. I don't think it goes in the surface area, but oh well.
Oh, okay. I'll move it down.
No, I think we can leave it there. Oh well, yeah.
It's fine. It's fine.
Okay. So next up, the next volume formula is for a prism. So I think it's talking about the well, yeah, no, not just a rectangular, but it's essentially the formula for a volume of a prism is the area of the base times the height. So we represent it as a capital B times H.
Well, we can also do like length times width.
Oh yeah, that also works. Length
Yeah.
times width times height. But I think it's just they're giving us like the general thing.
Oh, okay. Okay.
Yeah,
So
like for triangular prism, it works as well.
okay, that's true. So like for any shape prism,
Yeah.
for any shape prism, then the volume would just be the base times height.
The area of the base.
Oh, okay, yeah, the area of the base times height.
Yeah. So this also works for the cylinder. So yeah. I think it works for like all the types of prisms.
It does, yeah.
Yeah.
So the base would just be pi r squared
Yeah, pi r squared times h.
times h. All right, we should move on to
Doing some examples.
cones. Okay, we can do some examples too.
Okay, wait, do you want to do cones?
Yeah, I think we should do cones before examples.
Okay.
Okay, so what a cone is? Oh, by the way, a cylinder is just okay. So a prism is just any shape or any object that has the top face, that has a top face and a bottom face. They're the same, connected by like I don't know how to describe this, but you guys probably know what a prism is already. Okay.
Yeah. Kind of just elongate the shape.
Yeah, you kind of you elongate the base, and then you get this structure.
Yeah. Prism.
Prism,
Yay.
called prism. A cone, on the other hand, you have the same base. It could be the same base as a prism, but the top is actually just a single point, and you like extend. Still, it's hard to describe, but I guess I can just draw it in a picture.
I think everyone's kind of familiar with the shape of a cone.
Yeah, I think so too.
Yeah. Like, I don't think, is that a cone? Yeah, that technically is, I guess.
It is. A cone is just anything that ends in a point.
Yes.
Wait, actually, I guess we could call it pyramid because a cone is for like circles. Okay.
Describe it as a right triangle, but spun it about. Yeah, that's a way to describe like a circular cone.
All right, triangle and spun. Oh yeah, that's a nice definition. So a pyramid is anything that ends in a point, and a cone, I think, is just a circular base. Is a special type of pyramid. Can you confirm, David?
Yes.
Very awesome. Okay, so the volume for a cone is just 1/3 of the area of a prism if it had that base. So 1/3 times the base times the height. So for example, with a cone, the volume of this cone is 1/3 of the volume of the prism if it had the same base. So this part is equal to 1/3 of the total volume. Right. Should we like move on to examples now?
Let's do the surface area as well. Just talk about it.
Okay, sure.
Yeah, so for a circular cone, the surface area is equal to pi r squared times pi r slant height. So you can also kind of simplify this and just say that it's pi r times the radius plus the slant height. So the slant height is essentially basically, you could say if you were to use Edward's definition of that, like spinning a right triangle around a point, the slant height will be equal to the hypotenuse. Yeah, so the red line will be the slant height. Could it also equal to the triangle times the circumference?
Triangle times. Oh, it's
Not
not really a triangle.
Yeah, I mean, not sure if that'll work.
Oh wait, I get what he's saying. Okay.
Yeah, like if you can calculate the volume by spinning the right triangle.
Yeah.
Yeah.
Well, see, theoretically it would work out, but like if you do experimentally, it's 1/2 times r times the height. You multiply by 2 pi r, I believe.
Yes.
So you get pi r squared times h, but that's not really what the volume of a cone is. I
I
think
mean, okay. I think there is a way around this if you were to use like, wait, no, it wouldn't work at all. Never mind. I thought I got something, but it just wouldn't work at all.
okay. No, Edward, you're on the right track for calculus because you can definitely prove that with calculus. Essentially, the idea behind like using calculus to prove it is you have a lot of right triangles and you just sum up all the areas. But yeah, if you use calculus, you can definitely derive the volume with that technique. Do you want to move on to examples now?
Yes, we should.
Okay.
You want to just like draw a random shape, and then we can use
Sure.
the formula.
Mm,
Huh.
a sphere is resting on a circular prism. Calculate. The height is 5. The radius is 3. And the radius of the sphere is also 3. Okay, so we're trying to calculate the surface area and the volume.
Oh yeah, this is a very interesting one.
Yeah, well, you teach calculus in a different course. I think we would actually. Next year, we might be teaching Math 30. And if we do, we'll be teaching calculus.
Much of the sphere is covering the top.
Not at all, just a single point.
Yeah.
Just 1 point. But yeah, if you're interested, definitely subscribe to us. We'll tell you when our next course rolls around. Okay, David, do you want to start or should I do it?
Should we wait for an answer first or?
Okay, yeah, sure.
Just say round to the nearest 10. Do you think that's good?
Yeah. Or like even the nearest integer or something.
Oh yeah, I think that'll work as well.
Yeah.
Is that a circle on top of a cylinder or a sphere on top?
It's a sphere.
Ooh. Yikes.
Mhm.
Might have to leave out the thing that's on the. Yeah. Do you have to
Try to see the
leave?
decimal is.
Do you have to like leave out the like where the like the a spear touches the cylinder? Just include it.
It's a
Uh,
single point, so don't worry about like subtracting any contact areas. It touches it at a single point.
Okay.
okay, I think we have something interesting. I think there's 2 competing answers in chat.
There is. Oh yeah, there is.
Uh-oh. Wait,
Both
wait,
of
we're
them
getting
are
we're getting a change of answers right now.
yes, courtesy of decimals. Nice.
Okay, I think we got some firm answers in chat. Okay, let's just do. Oh yeah. Okay, so we actually don't know the answer, so we're gonna do it together to verify.
I think everyone is
Yay.
agreeing it's
Yeah.
oh wait. Okay,
Wait,
let's do it
Edward.
together.
Is 254 for volume or surface area? Oh, volume. Okay. Yeah, I think we got 2 volume answers, so we can do volume first.
Wait, I think one of them said volume and one of them was talking about the surface area.
Wait.
That's why they're mixed up.
Oh, okay. Yeah, that makes sense.
Yeah.
Yeah, okay. You want to do surface area or volume first?
Let's do volume first.
Okay. I think that's the easier one.
It is, yeah.
Yeah, okay. So I guess we could create a simple formula for this. We could just add the formula for volume of a cylinder. Oh, yeah. Okay, yeah, let's do the sphere first. So it's 4/3 times pi r cubed.
Whoops.
It's fine. And then plus 2 pi r times h.
Wait.
Wait,
Pi
hold
r
up.
squared times h.
Yeah, pi r squared times h. Whoops, my
It's
mistake.
fine.
And now we can just plug in the answers. We get 4/3 times pi times the other numbers. Uh-oh, I can't see what I'm doing. Here, I'll get the answers out within like a couple seconds.
Yeah, take your time. It's okay.
Yeah, I got 254.
All right.
Yes,
Neat.
so the volume is correct. Okay, and then the surface area. Oh boy, okay. So we got let's add the formulas together. So we get the surface area of a sphere, and then we have the surface area of a cylinder, which is 2 pi r squared plus 2 times pi times r times h. Yeah, this is nice.
Okay. Let's explain like the surface area for a cylinder.
Yes, that's a good idea.
Yeah. So for a cylinder, there are actually three surfaces. The first one is the top circle. The second one is the bottom circle. And the third one is this middle rectangle. So this is actually a rectangle. So the top one and the bottom one are both pi r squared. So those two sum up to 2 pi r squared. Now the middle one is actually a rectangle with a width of the height, so it's 5. And the length is actually the circumference of the circle of the base. So that's just 2 pi r. So that means the total surface area would just be 2 pi r squared plus 2 pi r height. So now let's plug in those numbers.
Yeah.
Okay, what do we get?
Well, I have a very different answer from Edward, but he said, "Oh, oops. Uh-oh. Okay. Well, I somehow got 263.8. What? I'm confused
Okay.
about what I did. Hold up. Is my calculator broken? This is nice. Wow. Okay.
I'll also do it on my
Yes.
David, what did you get?
Oh, what did you get, Kevin?
I got 264.
Oh yeah, okay. Yeah, well, if you round mine, you get 264 as well.
Wait.
Here, yeah, I think we're all confused somehow. Okay. Edward, not sure where you got that extra 2 from. Right after the 4 pi 3 cubed. Oh, 3 squared, I mean. For the 2, oh my gosh, okay, did we figure? No, we didn't. It's already 4 pi r squared, so it already includes the 2 circles. Wait, hold
For
up.
the
Are we
two
all confused? No, hold up. Wait. Oh, Edward, you calculated 2 spheres.
Yeah, okay. I was really confused for a sec. I thought we were both wrong.
Yeah, this is a fun that comes with geometry.
Yeah, everyone has like different answers.
Okay, yes.
Yeah, go ahead.
Uh-oh.
Oh, hi Jason. We're just learning about surface areas and volumes for today's lesson.
Yeah.
Oh yeah, I was in a different account. I didn't realize it's the same person.
Oh,
Oh,
okay.
okay.
Welcome back. Right, should we do a different problem or should we do some worksheet?
What did you write it? Yeah, I think we should do a worksheet after this.
Worksheet? Okay, sure.
Yeah. What did you write in your calculator? Edward, can you post in chat like what you typed into Desmos?
We just wrote this. Me and David
Yeah.
wrote this.
Oh, you multiplied the two formulas. Yeah.
Plus pi times.
Or uh-oh. Why is it still higher? Hold up. 5.
Wait.
Aw.
Why is it squared for the last part? Why is it squared?
That is very true. Height times circumference. Well, we kind of have the two parts. 2 pi r is the circumference times the h, which is the height.
It is height times circumference. But is the circumference is not, I think you mistaken the area for the circumference
Yeah.
because it's 2 pi r, not pi r squared. Yeah, I think, yeah, you wrote pi r squared, but it should be 2 pi r.
Oh, yay. Okay, yes,
Okay.
that's the correct answer.
Yay, nice.
Okay, let's move on to worksheets.
Pog.
Yeah, geometry. Honestly, if you saw a random number and a random shape, I think it'll be really hard to see what's wrong with the answer.
Yeah, it is. But thankfully, this isn't a super big unit, so.
Yeah. Here, should we do number 10? Another geometry one.
Oh, okay, sure.
Yes. Yes. Wait, should we like let them do it or do we do it together?
We should let them do it.
Okay. How do
Okay, so the volume is 1/3 times the area of the base times height. Yep, no problem. Oh yeah, sorry, I meant V. Thank you.
yes, all of those surface areas are correct, Jason and Pangxiong.
Yeah, great job, guys.
Yes, I think Edward's on the right track as well.
Yes.
The Pythagorean theorem. I don't think you have to use it though. Yeah.
Yeah, because
kinda-
this 8 is a slant height.
Yeah, it
so-
kind of gives you a lot of information.
Mhm. You do need to use Pythagorean theorem for the volume.
Oh,
So-
yes. Okay. Yeah.
Oh, okay, yeah.
Yeah.
You have to use it for the volume, yeah. Okay, let's do the surface area first because a lot of you guys are getting the surface areas.
Okay. So the surface area is for this right pyramid is essentially just the area of the rectangle at the bottom. plus the area of the 4 triangles. So it's, yeah, you can write that out. So the rectangle is pretty easy. It's just the length times width, which is just 5 squared. And then now what we have to do is that we have to add on the 4 triangles. So it kind of nicely tells us the base and the height. So yes, 4 times the 1/2 times 5 times 8. And that should give us the surface area. 25 times, yeah. Oh wow, you're too quick.
105. Mistype.
52?
52. That looks right. I think it's about
I
52.
I don't think that's right. Looking at here, maybe the answer sheet's wrong. Who knows?
It's not? Oh, okay. Oh, okay. I see. I see.
Yeah,
I think you forgot to divide it by 3. I mean,
yeah.
wait.
Here,
Oh.
honestly, I don't know if the answer sheet's right at all because we have Jason with like a different volume.
Oh,
Like
okay. Yeah.
2 people.
Let's just do it together then.
Yeah, I think we should.
Mhm.
Okay. So we obviously know the volume formula. So what we have now is to find the area of the base, which is just the area of the triangle of the rectangle, which is this 5 times 5. And then also the height, which is we just have to use what I'm assuming Edward did with the Pythagorean theorem to find out the height. So it's 2.5 and 8. So it's 8 squared minus 2.5 squared, and it gives you the height squared. Okay, so let's do that. And that is roughly 7.6. We can round to that.
All right.
The height.
so-
And so 1/3 times 25, which is the area of the base, and times the 7.6. Just a second. And that gives us 63.3, which we can just round to 63 centimeters cubed.
Okay, yeah. So was the answer key, right?
Yeah, the answer Q is right.
Oh, okay. Really, really close, Edward.
Yes.
I am triggered. Yeah, 63. Oh, okay. Yeah, that's a
Yes.
really common mistake. You're not the only one, don't worry.
Yeah.
So yeah, when you're finding the height of the triangle, you have to use half of the base for the bottom side.
Yeah, if you're like unsure, you could always just draw out the triangle and see that, oh wait, it can't be 5 because it's too short.
Yeah, that's also a really good way of doing it. All right, does anyone have any questions on this one?
Sure, you can take a screenshot.
Yes.
Do we do another worksheet question?
Yes. So we're pretty
Yeah.
much skipping all of this.
Yeah, I feel like that's pretty easy.
Yeah.
Okay, which one seems most interesting to you?
What about which one seems most interesting to you? Because I'm fine with doing either 11 or 12.
Should we do 12?
12?
Hmm.
Okay,
I mean,
sure.
okay, well, no, I think 12 is pretty simple. It's just a right cone.
Oh, okay. Let's do 12 then.
Okay, yeah, wait, I'm not sure how they got a cone with a 2D plane.
Uh,
Um,
no idea. We should just skip. We should just like do 11 then.
yeah, I mean, I think 11 is pretty interesting as well.
It is, yeah. Okay,
Yeah,
let's do 11.
Yeah, if you're unsure what a hemisphere is, it's just a sphere that's been cut in half. Yeah, so it's a great drawing right there. Yeah, it's 3D.
Bro, yes. 3D.
Can we use pi instead of just estimating it?
Yeah, if you always have the like a really accurate value of pi, you can use it.
Yeah.
Yeah.
This is
No,
like
I'd rather just
3.14.
say pi. I like using pi, but it doesn't. Well, 3.14. 3. Is common, but I like using pi. But
That's fine too.
And I think Edward has got the correct answer for the volume.
Yes, that's correct. Great job.
Yeah, I think we can go over how to find the volume. Yeah, it's quite
Mhm.
simple because what we essentially did was cut the sphere in half. So the volume will also be half of the original sphere. So we can just kind of put the original formula and just divide it by 2. And we get, if we fill in the numbers, we get, yeah, roughly 3,619.1 meters cubed.
With your units?
Yes, very important units.
Oh,
Yeah, meters.
meters. Okay, now for the surface area, should we just quickly
Yeah.
go over it?
That's not correct, Edward, but you're almost like you're kind of close to it. Yeah, I think we
can
could
I
go over
see
surface.
the questions? Really?
Yeah, let's just do the surface area like underneath question 12.
Okay.
Yeah.
Surface area.
So it's going to be a little different. So we obviously have half the surface area of the sphere, but we also have made a new surface with the cut, which is just a circle. So yeah.
Yeah, it's just a cross-sectional area. So we can't forget about that. Okay, what do we get?
So we get 1,357.2 meters squared. What the answer sheet says, but I'm just going to double check anyways.
I think that's correct. Yeah, that's correct.
Okay, yes, it's good.
Wait, can you say it again? The answer?
1,357.2 meters squared. Yeah, just 0.2 and then meters squared. Yes.
Okay, awesome. Really close, Edward. Definitely on the right track.
Yeah. I think you might have forgot something like the circle or yeah, it didn't calculate
Yeah.
bottom.
Common mistakes. Don't worry.
Yeah.
Okay, it's 5, so we're gonna end our lesson here. It's been so fun teaching all of you guys, and this will be our last lesson.
Bye. I hope
See ya.
I'll see you again in another lesson.
Mm-hmm.
See you.
Yep. See you.